Hello everyone, welcome back to another exciting session for ICSE Physics. This session happens to be for all class 9 students, right? And this is the topic for the session. In this particular session, we are going to discuss laws of reflection, right? And the concluding part of the session will highlight the basics of a plane mirror as well. I'll be telling you how images are formed in a plane mirror, what all are the necessary conditions. What are the conditions? An image can be formed for a point object, the image can be formed for an extended object as well. But the image formation part is rather related to the very basic principles of optics, the very basic being the laws of reflection. So if you understand the basics of laws of reflection, 100% I'm sure that you're going to understand how the images are formed. Okay. So what we have to focus on rather is the basic rule which decides how the images are formed, right? And this particular session is going to take you along this particular route through which you will be able to form the images. Before starting the session, in case you are attending my session for the very first time, let me introduce myself. My name is Kalyan Krishna Awasthi, and as far as my qualifications are concerned, I have done my master's in electronics, MTech in electronics rather, and as of now I'm pursuing my PhD, that too in electronics. And I have been teaching physics since 2008-9, so I have this experience with me which can be very beneficial for all my students, right? This is the link for the Telegram channel. This one is for the general ICSE and ISC channel, so you can attach, you can connect through Telegram, and once you connect, you will be updated with all the upcoming sessions of all the educators. Everything will be updated on this particular Telegram channel, right? And we have one more channel. This is my channel, the physics channel, K Awasthi. And I would request all the students who are following my videos to connect with me through Telegram. You'll be updated with all the upcoming sessions, each and everything, sample question papers, everything will be updated on this particular Telegram channel. So it adds value to the preparation, and it creates a sense of connectivity as well between the learner and the educator, which as of now it's very, very important. Okay. Now, like I always do, before starting a particular session, you have to know the backstory. The backstory is what that matters. If I tell you directly about force and I do not tell you about mass, how will you be able to relate the force part? So if you are starting with light, optics rather, preferably we should rather call it optics. So if we are starting with light or optics, you should first try and understand what are the terms that we are going to use during the course of the session. Okay. The very first is an object. Okay. Now, object I have classified as two objects, a luminous object or a non-luminous object. As the name suggests, one of them will obviously be emitting the light, like sun. It always emits the light on itself. We don't have to kind of show a torch to the sun and then it will be bright or something like that. No. So there are certain objects which are luminous and certain objects which are non-luminous. We do not emit light themselves, they rather reflect light. Okay, so we have to be very particular with this particular aspect. The second one is the medium. Now, we have studied in sound as well, medium plays a decisive role for any kind of reflection, refraction, or whatever optical phenomena you're going to study in the subsequent sessions or maybe in the subsequent years. Medium plays a vital role, right? See, if a medium is transparent, you have already kind of visualized it, you have seen it in the real life. The light does not pass a wood, it does pass through a glass and partially passes and reflects and transmitted and all things through a paper. So medium plays a very, very important role when you are deciding on the propagation of light rays. Okay, so you have to focus on three particular mediums: a transparent medium, a translucent medium, and an opaque medium, right? The third part is the ray part. This happens to be the most interesting part. And why am I calling it the interesting part? Reason being, we keep on using the word ray quite often in almost every diagram. In fact, we call the diagrams as the ray diagrams, if I am not wrong, and if you're getting me right. We normally the question says draw the ray diagram when the object is at, say, focus. Okay, so what does this ray means? Ray signifies a straight line path along which the light will travel. Okay, I mean, light has n number of options to travel, but for a particular situation, whichever path light is adopting, whichever path light is following, that path will constitute ray. Okay, in optics specifically, we'll be coming across three types of rays. The very first is a convergent ray. I mean, if it appears that all the rays are meeting at a point, fine, you can clearly notice that all the rays here are meeting at a point, so this will rather be called a convergent ray, right? What is a divergent ray? In certain applications, in certain image formations, in certain spherical mirrors rather, you'll get to see that at times it happens that the light is diverging from a point. So whenever a ray diverges, you call it a divergent ray. Okay, and then lastly we have parallel rays. What are parallel rays? These are parallel rays. I mean, the light ray travels in a straight line and the rays are equidistant. Okay, see, these rays are equidistant. All the rays are at same distance from each other. So in the entire session, in fact, in the entire optics part, in the entire light part, we are going to focus on three different rays: convergent ray, divergent ray, and parallel rays. So I hope it's good to go. We have understood the very basic terminology that we'll be using: object, medium, and ray. Fine. Now let's see what reflection actually is and how does it take place. Now, whenever a light ray strikes up surface, I mean, it can be either surface, any surface, what happens? I'll be telling you two important things. Let us suppose this is a surface, okay, and a light ray strikes this surface here. It can strike at any oblique angle. The angle of incidence is irrelevant. I mean, it can be any angle of incidence. We'll be discussing it in the same very lecture, how the angle of incidence influences the propagation of light. What actually happens? Some part of the light ray returns back in the original medium. Let us suppose this is medium 1. Okay, this is medium 1 and this is medium 2. Okay, now what happens? We'll first be talking about reflection only. So what reflection is? When a light ray is incident on a surface, a part of it returns back in the original surface. Okay, a part of the light, it bounces back in the same particular medium, right? See, you have seen that the light ray was incident from medium 1. This was the incident ray. Let us call it the incident ray, and this is the reflected ray. What we can see is a light ray was incident on a surface in a medium, and a part of the incident ray returned back in the same medium. Now this phenomena is called reflection. Okay, so if somebody asks you what is reflection, you should rather reply, reflection is the phenomena in which a part of the incident light ray returns back in the same medium. See, I always emphasize on writing the definitions or concepts in your language. Okay, it's not necessary you use the exact language that is written in the book. But for that, you have to kind of understand the concept very clearly. If you have understood the concept clearly, you will be able to replicate whatever you have understood. Yes or no? So for us, what is reflection? Reflection is the process in which a light ray, when incident on a surface from a medium, a part of it returns back in the same medium. Now the question is, practically, does all the rays reflect back? I mean, that's a very, very basic question. It doesn't happen that way. Okay, but we have to focus on reflection only, so we won't be dwelling into the other parts. But for example, say 50 rays are incident. and say 47 are reflected. Let us suppose that the surface is very well polished. When we increase the the reflectivity of the surface by polishing it or otherwise, then maximum rays are reflected back, but still there is a possibility that few of the rays never return back. Now what happens to those rays which haven't returned back? There are two possibilities. Either the surface has absorbed these rays completely, this is one possibility, or you have one more possibility. Some of the rays were actually refracted, I mean they crossed the surface, right? So when the rays cross the surface and reach the other medium, see, I've clearly shown you this is medium 2. Yes, this is your medium 2. In case some of the rays bypass this medium, this surface, and reach the medium 2, then we call it refraction. Okay, but since the session is dedicated to reflection, so we won't be highlighting these particular aspects. We will be sticking to reflection solely, right? Now just see this particular point. Reflection is highly dependent on the surface on which the light is incident. I mean, I have just told you, if in case I could increase the reflectivity, by reflectivity I mean to say, in case if I am able to polish the surface, what will happen? Maximum rays will reflect back in the same medium. This is how reflection takes place. Okay, in reflection the surface plays a very vital role. It has a decisive role to play. A highly polished surface or a silvered surface reflects almost the entire light falling on it. This is what I meant to tell you, right? I hope so far it's good and you've understood all the topics. Let's move on. Now see, we can classify reflection into two types. And what is the parameter on the basis of which I am classifying reflection? The parameter here is the surface. Just look at these two surfaces. You can clearly see that this looks a regular smooth surface, right? Smooth, or rather call it a regular surface. And then we have another irregular surface. This surface is irregular. You can clearly see the difference between the two surfaces. Now see, what role does surface play when we are analyzing the reflection part? Now in this particular scenario you can see that, see, both the cases, this is a beam of incident rays. These are incident rays and they again are incident rays. Okay, so incident rays in both the cases are parallel. Now when these incident rays strike a plane surface, you can clearly see that the reflected rays are following a pattern and these are also parallel. Why? Because the surface was absolutely smooth. I mean, there was no irregularity. It's like this. I mean, let us suppose this was the surface. A ray struck here and it reflected that way. It struck here and it reflected that way. I mean, there was no irregularity in the surface. So all the reflected rays were actually reflected parallelly. Now, if I want to see them from here, I can clearly see all the reflected rays following a single pattern. I mean, all the rays are reflected in a single direction. We don't have difference in the direction when we are dealing with the reflection at regular surface. You can clearly observe this. On the contrary, let's analyze the reflection at irregular surface. What happens here? You can clearly see that these are the incident rays. These incident rays, when they fall on this irregular surface, now irregular surface has granules. I mean, it's very irregular. Let us suppose a light ray is incident here. Now, for example, it is reflected in this direction. If a light ray is incident here, let us suppose it's reflected in this particular direction. Again, when a light ray falls here, it might be reflected here. Why is this irregularity in the reflection pattern is being observed? Because the surface is rather irregular. You can clearly see the surface is rather irregular. Because of the irregularity in the surface, you cannot collect all the reflected rays at a single point. You cannot collect them. Why? because all the reflected rays are following different pattern. Yes. And why are they following a different pattern? Because the surface was irregular. Every incident ray suffers a reflection at a different angle, which is, which has nothing to do with the original angle. So this is where things add up, right? I hope you have understood what I'm trying to convey. Okay, fine. Let's, summarize this. I have prepared this difference chart so that you get to understand it in a single go, in a single shot. Light beam, yes, obviously the very first point has to tackle with the polishness and smoothness of the circuit, of the surface rather, not circuit. And in case of irregular reflection, you can clearly see that the surface, not circuit, is rough, right? Now, the second point, which I've already shown you in the diagram, all the reflected rays are rather parallel and they can be tracked. I mean, they can be visualized from a single point. But this is not the case for irregular reflection because of the irregularity in the surface, right? I hope the logic is pretty much clear. Now, let me tell you guys about the unique features of Unacademy special classes. The very first thing is that the classes are absolutely free, so you don't have to kind of bother about that. And what are the features? Let me brief you about the features. You get to interact with the educator in real time. It's a live interaction. And how can you interact? You can interact with the educator using the chat box and the emojis. You have this chat box, you can clearly see this is the educator taking a class live, and you can clearly see the learners interacting with the educator. See, in YouTube, you do not have the facility to interact with the educator live. I mean, if you're watching this lecture, you want to talk to me, you have any query, you have only one option, that to a chat box, and that too when I am enabling and I'm replying. But in case of special classes, in real time and in YT sessions, at times there is a lag as well. I mean, for example, say 5 students have send me a doubt, so I'll be receiving the doubts at different times, and by that time I'll be on to some other topic. So there is a lack of synchronization. But in special classes, you don't find it. You can interact with the educator on live basis, real time basis. That is the best part. Okay. Second, there is a question tab as well. You can anytime use that tab and send your doubt. You can clearly see here, right? This sort of a window will open. You can write your question, like what is reflection. For example, you didn't understand what is reflection, you can type here or send. Or for that matter, there is a certain ray diagram which you're not able to decode. See, here is the option for attach an image. You can clearly attach an image and send me. I'll instantly get to know your doubt. So this adds value to your preparations. And on top of that, in special classes, we have a lot of live polls. Now, what does a poll mean? I mean, it's a sort of quiz that we conduct live, and you get to see your performance live. You can see poll summary, right? The person, the student, the learner who has topped the chart, it is visible there. So it again adds value. I mean, you get to know about how about your performance, how well are you performing, how much time you are taking to get the answers correct, right? And in case you want to opt for this special classes and you want to unlock any of the logged classes, you can rather use this code Kalyan Live. This is my code, guys. This is my code. What you have to do is, if you're finding my sessions interesting, just download the Unacademy app, type my name, you'll find me, you'll find an option for the free special classes. Just click on that. In case the class is locked, what you have to do is you have to use this code. Once you use this code, the classes will be unlocked. Right? You can watch those classes. That adds value. Now let's talk about the law of reflection. Okay, see, there are two basic laws. The very first is the angle of incidence is equal to the angle of reflection, and the second one is the incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. You have been kind of studying these laws for class from class 6, 7, 8, 9 maybe, but there's no problem. I'll be telling you in a more elaborative form. Rather than, the theoretical part, let's see how things go. Let us consider a surface. For example, this is a reflecting surface. Now, we are focusing on reflection, so we'll be dealing with reflection only. We have nothing to do with the other rays. This is an incident ray. For example, this is an incident ray. Okay. Now, whenever you encounter an incident ray, the very first thing that you have to do is you have to draw a normal. Now, see, this is a normal. See, normal means 90 degree. So, a normal is always 90 degree. Okay, to the surface on which we are actually discussing the reflection, right? So if this is the surface, this is the incident ray, this is the normal. Now, in accordance with the laws of reflection, the light ray will be reflected. Let us see, let us say this is the reflected ray. Okay, this is the reflected ray and this is the incident ray. Okay, now the very first law says, it doesn't look equal in this particular figure, but the very first law says the angle of incidence is equal to the angle of reflection. So what happens? The angle of incidence is equal to the angle of reflection. The very first law says that the angle of incidence is actually equal to the angle of reflection, but many students make this mistake. You don't have to take this angle as the incident angle. No, the angles are always taken from normal. Okay, just make a note of this point. We take angles from normals. Okay, we always take angles from normals, right? So this is the angle of incidence, this is the angle of reflection, and angle I is equal to angle R. This is what the law says. I hope it is pretty much clear. And the second part of the law says the incident ray, the reflected ray, and the normal, this is your point of incidence. Point of incidence. The incident ray, the reflected ray, and the normal at the point of incidence, all of them lie on a same plane. Okay, so these are the two laws of reflection that you have to kind of discuss. Okay, so far so good. I hope you have understood the logic. In the subsequent part of the chapter, what we have to do is just imagine that this reflecting surface is a plane mirror, right? The only difference that you'll notice is that this reflecting surface becomes a plane mirror, and that deals with the plane mirror part of the session. Okay, now a very important thing, what if the incident ray is normal? This is a special case. Let's see, what if the incident ray is normal? Let us suppose this is the normal and this is your incident ray. This is your incident ray. Now what will happen? See, the law of reflection says that the incident and the normal ray, the angle of incidence and the angle of reflection, they are equal. Now see, if I is falling normal, how much angle is I making from the normal? This is normal and this is I. So there is no angle between it. I and normal, this shaded line is the normal and the darker one is the incident ray. This is the incident ray. Okay, now when the incident ray is normal to the surface, the angle between the incident ray and the normal ray is nothing. Zero angle. So what will happen? The reflected ray also has to have a zero angle. So what happens? The light ray, as it incidences, it reflects the same way. Okay, so whenever in a ray diagram you get to see this kind of a situation, you have to automatically understand that incident and the reflected rays, if a ray is bouncing back on the same path or maybe it is retracing its path, you have to understand that the ray is incident at the normal angle, and this particular condition is called normal incidence. Okay, we call it normal incidence. I hope it's pretty much clear to all of you. Yes, good to go. Fine. Now, what are the constraints? How will you get to know that image is formed? Is there any specific logic behind the image formation part, or for that matter, how you'll kind of go about. So there is one basic rule. Okay, one basic rule. If you wish to visualize the image of an object, the only thing that needs to be kept in mind is that at least two rays must intersect. Now that's very important and very logical either. Two rays have to intersect. If two rays are not intersecting, you're not going to get an image. Okay, later on, when we'll be discussing spherical mirrors, you'll get to know that these rays are called convenient rays. Okay, these rays are called convenient rays. For image formation, we need convenient rays. This is not the session where I'll be discussing this, but maybe in the next session where I've taken up spherical mirrors as the topic, I'll be telling you about convenient rays. Okay, whenever two rays intersect, only then there'll be an image, otherwise no image will be formed. Now there is one more constraint. It's not necessary that the two rays actually intersect. It might be the case that it appears as if the rays are intersecting. Now this is a catch. It's not necessary that every time the rays actually intersect. It might happen that they appear to meet, right? So this again is an important constraint. So you have to keep this in mind as well. They might actually meet, or they might appear to meet, or they might appear they might appear to come from a point. That is the case for spherical mirrors, right? Now we're talking about the formation of image, so we should rather have a very basic idea on how and what kind of images can we have in a plane mirror. Rather, now the focus shifts towards the plane mirror. Okay, see, the real and the virtual image you'll find everywhere, but since the session strictly focuses on plane mirror, so I'll be kind of explaining you this in terms of a plane mirror. So the very first kind of image that you can get is a real image. Okay, and what is a real image? A real image is the image that you can actually get on a screen. It actually is formed on the screen. Okay, and when is it formed? A real image is always formed when the rays, the reflecting rays, they actually meet at a point. Okay, when these reflecting rays actually meet at a point, you say that a real image is formed. Okay, and in almost maximum cases you'll always find an inverted real image. Okay, you'll always find an inverted real image. So these, at times you get MCQs where this question is asked. They say that an image is formed of the object. Which kind of image is that? So if it is inverted, you have to understand that it might be a real image. And this was the first type. The second type is a virtual image. And how to go about a virtual image? A virtual image cannot be obtained on a screen. Virtual, the name itself explains you everything, that the image indeed is a virtual image. What actually happens here? The two rays actually, they do not meet. It appears as if they are meeting, or it appears as if they are converging or diverging. Okay, they might appear to meet, but they don't actually meet. When we'll be discussing the image formation of the spherical mirrors, I'll be showing you different cases where you can visualize the formation of a real and a virtual image. So that will be more realistic for you to imagine. As of now, you can just remember that two images are formed. First is the real image, which is obtained, it is inverted. The second one is a virtual image, which is erect. Okay, this inversion and erection is with respect to the size of the object. Fine. Now let's take up this question. I can give you 30 seconds to think how you can solve it. Once you are studying a concept and you get to solve a question instantly, it kind of adds value to your preparation. So that is what I'm trying to do. I'm trying to add value to your preparation. Can anyone tell me? Just pause the video, solve it, and check if you are able to get the correct answer. It's a very basic question that involves very basic understanding of the topic. You can clearly see that this is an incident ray, a normal, and a reflected ray. This is the angle of incidence. This is the angle of reflection. Now, let me tell you how to go about this. See, you have to find the angle of reflection. Now we know that as per the laws of reflection, the angle of incidence is exactly equal to the angle of reflection. This is what we know. So in case we are able to find I, we'll automatically get the value of R. And this is what we have to do. Now how to find R? See, if this is a normal, then this angle has to be 90, right? The name itself suggests that normal means the angle is 90. Yes, and this particular angle is 20. It's given. See this angle, this is 20. So what I can say is I plus 20 is equal to 90. Yes, this is I, this is 20. I plus 20. See, this is I plus 20. I plus 20 is 90. What I have to find is I. So I will be 90 minus 20. This will be 70 degrees, and we know that I is equal to R, so R will also be 70 degrees. So what is the correct option? B is the correct option. Okay. One of the students told me that in most of the cases C is the correct option, so don't bluff that way. Here B is the correct option, right? Fine. Now let's see another. This is a very good question. Very good question, and it's a very conceptual question as well. See, the best part is if you study or read a concept and you get to solve a question immediately on it, then it adds value to your preparation, and that is what we try to do at Unacademy. Just look at the question carefully and try to kind of decode it. Let's see what the question says. The question says, in a dark room we have a plain mirror and a wall. Fine. See, this is a dark room. Let us assume this is a dark room. These are the four walls, and we have a same mirror, plain mirror. So this is a plain mirror. This has to be a polished surface. Okay. Which is the correct statement? Now you have to find the correct statement. If anyone wants to answer, they can answer in the chat box. I'll get to know what do you want to reply. I'm giving you 30 seconds. It's a very logical question. Anyone who's attending the session, if he or she wants, you can reply in the chat box. I'll get to know what you have replied. Just read the question carefully. Okay, Abhinav Sharma is saying B. Okay, Abhinav. Okay, Abhinav, you are saying that reflected light from the mirror can be seen everywhere. Fine. Now see, can you tell me, Abhinav, which concept have you used in answering the question? It's very important to decode things. Abhinav, which concept have you used to decode this and tell me the answer? What was the underlying concept for this? Yes, Abhinav. How did you get B as the answer? Let me give you a hint. Let me give you a hint and make it a bit more interesting. The question is based on regular and irregular reflection. The question is based on regular and irregular reflection. Now you want to change your options. See, a plane mirror. Just note what I am saying. A plane mirror obviously is a smooth, polished, reflecting surface. Yes, a plane mirror can be regarded as a smooth, reflecting surface. Yes. In case of a smooth reflecting surface, what happens? Just see these slides which I have told you. Just see this particular. Now you'll get a hint from this particular slide. Reflected rays can be seen from a fixed direction. Okay, now let us suppose a rays incident and it is reflected. Rays incident, it is reflected. A rays incident, it is reflected. Now, it can be from any direction. Okay, now Abhinav has changed the options and he's saying A. Let me again correct it. No problem. Hi, Muhammad Uzair, how are you? No problem if you're from CBSE. This is a very basic concept. Reflection and refraction is in every board, be it ICSE, CBSE, or any state board. So this is going to excite you in either cases. Now, what I'm saying, Abhinav Sharma. Uh, Now the regular reflection says that the light ray will be observed in a particular direction only. So, this B is out of context. This cannot be the correct answer. Okay, this cannot be the correct answer. You cannot have B as the correct answer. Okay, that's good, Muhammad Uzair. I guess you're attending the session for the very first time. I hope you're doing well. In case you find the sessions interesting, you can select the topics from your board and you can be a part of the sessions subsequently, right? It's not going to affect your prospects, I guess, right? So now, who will tell me? I didn't see you, beta. I didn't see you. Now I'm talking about you as well. Okay. Yes, Muhammad Azhar. Now you have just messaged me, so I got to know that he that you are here. Otherwise, I mean, I cannot see the attendees unless and until you message me. How will I get to know that who is present? Abhinav is a regular visitor. I mean, he quite often uh, comes in a live streaming, so I could instantly relate with him. Next time around when you'll come, I'll instantly say a hi to you. Right, Muhammad Azhar? That's good. I mean, it shows your sincerity being a CBSE student. If you're attending a session, that means you are interested in the topic. That's very, very good of you. Okay. Now, Mr. Sharma, wall can be regarded as a smooth surface or an irregular surface. Obviously, it's not a smooth surface. Yes, Muhammad Uzair. Uzair. Wall cannot be regarded as a smooth surface. I mean, now don't be very specific that in my walls, in the walls of my house I have done plastic paint, sir. It's very irregular. It's very regular. No, it cannot be regarded as a regular surface. Okay. Now if wall is an irregular surface, so what will happen? You can see irregular reflection, and what you observe in irregular reflection is when the yes, in general it is irregular. So irregular reflection can be observed at varying angles. You can see here. Just see. Just see. I mean, this is the scope. This is the scope. I mean, from any damn angle, you can observe an irregular reflection. So that goes with option C. Tell me, can C be the option? Reflected light from the wall can be seen only in a particular direction. Can it be the correct option? No, it cannot be seen from only a particular direction because wall is irregular. Okay. Now, A option cannot be correct because it's not the fact that nothing can be seen. No, it's not the fact. You can see things. So what should be the correct option? None of these, right? This was a very conceptual question and I have deliberately taken these questions. I am not sure whether you guys attend my poll wars or not, but if you want to have good questions, you want to see very good questions, I would rather request both of you, all three of you are in the session, to attend a poll war. We are having a poll war in the next class. Okay. So maybe, okay, yeah, Abhinav, I know you did. You attended, I mean, and you performed very well. Yes, I remember you attended it. And we had discussed 30 questions, 30 polls in that particular session. Okay, fine. Yes, Abhinav. Okay. So let me brief you about this Unacademy Prodigy test. I'm sure many of you must have already attempted the exam, but in case you have missed on it, the last date is Feb 13. Okay, so you can very well enroll in these particular exams. And why am I pitching it quite often in almost every session? Because The enrollment part is absolutely free. I mean, you don't have to pay anything to get enrolled in the test. Okay, and on top of that, you get a chance to win a number of prizes. Okay, I'll be showing you the slides which tells you what prizes can be won. This is the schedule. I mean, these tests have already taken place. This is the last date, Feb 13. So if in case you have missed out, you can rather participate on Feb 13, right? These are the prizes that can be won, right? These are the prizes. A rank 1 holder will get a MacBook Air, and then you have a chance to win an iPhone, an iPad, Amazon Echo Dot, and a lot of Amazon vouchers. Okay, so this indeed is a very good opportunity for all of you. You should rather take part in it. And let me tell you about the batches that we are having. We are having two batches right now. One is the champions for class 10th, and the other one is the champions for class 9. In both the batches, the mode of delivery is English. I mean, the content will be delivered in English, and the best part is, if you subscribe for class 10th, you'll be getting 11 to 12th. I mean, if you are in 9th, you get 10, 11, 12 free. If you are in 10, you'll get 11 and 12 free. This is the best part of these particular sessions. And the basic Unacademy subscription features which add value to your preparation. The very first is you get to learn live from the comfort of your home. You get unlimited access to all the study material. You get to learn from the top educators of the country, which again is a very good thing. There are regular doubt solving sessions, and the course coverage, the batches, live test, and these are the added perks to it. So it's not a bad deal either. This happens to be my code, and you can use this one, you can use this one as well, Kalyan Live. Okay, this is my YT code. Rather, don't use this one here. Kalyan Live is my YT code. You can use this code, and once you're using this code, you will be getting 10% discount. I have already told you about this code in the earlier part of the session. Okay, now let's talk about the plane mirror. See, a plane mirror indeed is a surface, a mirror which has one polished surface. Abhinav, I have shared the link on the Telegram channel. This is the link of the Telegram channel. I hope you have already joined. In case you have not joined, this is my personal Telegram channel, the Unacademy channel. Okay, so you can join, you can connect on this channel, and just okay. So I have just I've dropped the link there, and I'll be dropping a link again before I go live. 5 minutes earlier to that, I'll be dropping the link again. So you don't have to worry. What you have to do is just follow me, and you'll be updated with everything. Connect through Telegram. Everything will be diluted there. Okay, fine. So this is what a plane mirror looks like, and there is one mirrored surface that we called a polished surface, and there is one reflecting surface. Now see, let's decode how things happen. One arrow, first incident ray, second arrow, second incident ray. In accordance with the laws of reflection, this is the first reflected ray, this is the second reflected ray, right? Incident ray, angle of incidence, angle of reflection, angle of incidence, angle of reflection. What happens with the plane mirror? The rays are not actually meeting. If you extend these rays behind the mirror, you'll get to find a point where you will see the object. The best part here is the length of the object. If this is x, the length of the image will also be x. Okay, and that's very easy to understand. I mean, how does this happen? It's very, very easy. I hope many of you, I mean, I've told this derivation earlier as well. What you have to do is you just have to take these two triangles and you have to prove them congruent. If the two triangles are congruent, then this x and x will obviously be equal. In fact, they are equal. The only thing is that we have to prove it. Okay, so there's no point. This is a common line. This is 90, this is 90, and you'll be getting equal angles here, right? So this way you can very well solve them, and you'll be getting equal values rather. So that adds that sums up that the distance of the image and the distance of the object from the mirror are equal. And it's not always necessary that you'll be getting a point object. You might get okay, you might get an extended object as well. So, okay, so in case you have an extended object, you can clearly see what you have to do. You have to take two rays from the top part, two rays from the bottom part. Again, the basic law is same. The image will exactly be at a distance same as the distance of object. So these ray diagrams, both these two ray diagrams, what do they suggest? They suggest that the distance of the object from the mirror is exactly equal to the distance of the image from the mirror. And we have derived it as well in one of the sessions. I mean, one of the previous sessions, I have given you the mathematical derivation of it as well. Now, few students get confused with the extended object. So, what is an extended object? When, in comparison to the mirror, the object has a considerable height, we call it an extended object. As simple as it goes. Okay, right? So this is how it goes. Fine. I hope you've understood what I'm trying to convey. Yes, so far so good. Okay, now let me tell you about my special class timetable. Now see, tomorrow I am having a one-shot revision on magnetism, right? See, after every class we have a pole war. We have had a revision of current electricity and a pole war on current electricity. So tomorrow I'll be revising magnetism in a single shot, and on 9th we'll be having a pole war on magnetism. What you have to do is you have to download the Unacademy app, and you have to enroll for these particular classes. On 10th of Feb, I'll be revising the propagation of sound, and on 12th of Feb, we'll be having a pole war on that, right? I hope you've understood. So this is all from my side for today's session. I hope you found the sessions interesting. In case you haven't subscribed us on YT, this is the right time to subscribe. Subscribe Unacademy ICSE and ISC class 9th and 10th. In case you have not downloaded the app yet, you can download the app and you can use the code Kalyan Live. Kalyan, Kalyan Live. This is my code. There's some problem with the tab, so no problem. Kalyan Live, this is my code. You can use that code. Okay, fine. I guess let's end the session. This is all from me in this particular session. Hope to catch you again. Thanks everyone.